Hi guys, today I'm going to show you how to connect Raspberry Pi to APC UPS over the serial link and manage the UPS directly from Raspberry Pi. For this we are going to use a service named as APC UPSD. Once APC UPSD is installed, we will see how to use a Python script to push all the power related notifications to MQTT Broker and from there to MQTT clients. So in this tutorial, we will have three portions. First one would be related to installing APC UPSD on Raspberry Pi. Once this is done, we'll see how to configure a Python script so that it can push the notifications to broker. And in the last section, we will see how to test this entire setup. Okay, so let's start and install APC UPSD on Raspberry Pi. As you can see, I'm logged into Raspberry Pi using SSH and I'm running Raspbian OS on this. So I'll go ahead and use apt-get command to install APT UPSD. So sudo apt-get install APC UPSD. So this will install the daemon on Raspberry Pi, and once it is done we need to change a couple of configuration files so that it can talk to APC UPS. So the installation is done. Now we need to make some changes in the configuration. So the first file is APC UPSD conf file, which is in etc APC UPSD directory. So I'll use vi to make the changes. So etc apc upsd and the file name is apcupsd.conf. Okay, so as you can see, there are many variables. You need not to change all of them, just follow the documentation and the instructions in the file. So I'll change the UPS name. So this is the entry which you will see in the log files and even in the notifications and things like those. So yeah, so I'll make it as APC UPS. Now the next variable is cable. So this one you need to check the documentation for your UPS, but for most of them cable type would be USB. So I'm using APC back UPS. So if you're using the same, you can use USB as cable type, or else so you can check the documentation. Now the next one is UPS type and device. So again, UPS type for my UPS is USB. So I'll make it as USB, and device I'll leave as blank because the APC UPSD will be able to detect it automatically. So I'll remove all the text from there. So yeah, so we are done with the file configuration. I'll save the file and exit. Now there is another file which we need to change, and it is under etc default directory, and the file name is apc upsd. Now in this file you see there is a variable named as is configured. So now as we have made all the changes in the file, from no we will make it to yes. Again save the file and exit. Now we are done with the installation. APC UPSD is installed on this, so we can directly go ahead and start the service. So the file is located in init.d directory. So we'll start this. Now you see the service has started. Now if I run the status command for this service, I'll be able to see lots of data which will give us information about the UPS. So if I do service APC UPSD status. So you see, um, there is lots of information on the screen, which is related to the UPS, right? So you can check all these things if you want. You can parse them and can use them into your program if you want to display it onto a web page or something. Okay, so with this we are done with the installation. In the next part we'll see how to make changes in the file and enable MQTT on Raspberry Pi so that it can send all the events which UPS will send to Raspberry Pi onto the MQTT broker, from where you can get those events onto your MQTT clients. Okay, so let's install a Python script which will take all the UPS events and pass them to MQTT Broker so that you can receive them on your MQTT clients using the topic. Now, for this Python script to work, you need to make sure you have Python 2.7 install working on your Raspberry Pi, and as we are going to use Mosquito MQTT Broker, we need to make sure that we have Peho MQTT module installed on Raspberry Pi. So though I have Peho installed on my Raspberry Pi, but I'll execute the command so that you guys can check this. So we can do it with pip install Peho MQTT. So this is the command that you need to run on your Raspberry Pi. It will not do any harm, so I'll go ahead and install it. Right, so it says requirements already satisfied for my Raspberry Pi, but it will install Peho MQTT on your Raspberry Pi if it is not installed. Now, once this is done, you need to download the Python script from my GitHub repository, and to do that you can use wget command, and this should be downloaded in a specific directory. So I'll define the directory here, and it should be etc apcupsd. So this is the directory where you need to download the file, and this is the link for the repository. Don't worry about this, I'll put all the details in video notes. So let's go ahead and download this file. Now the file is downloaded. So now I need to make some changes in the file. Because this file is a Python script which will publish some information onto MQTT Broker using a topic. So you need to make sure you have your own topic which is unique enough. This is just a sample, so I'm not using any password or any kind of security with this. If you want, feel free to tweak the script and make the changes which you want to have. Now I'll show you what all you need to change in the file once you have it downloaded. So I'll use vi etc apcupsd. This is the directory, and this is the file. So in this file you see these two variables, MQTT Broker and MQTT Topic. So now broker, if you want to use a Mosquito Broker, you can leave this variable as it is, but I would suggest you to change the topic. Have something very unique to yourself. You can divide it with the /, so you can start it with like country, state, city, street, house number, things like those, so that it's unique enough. Okay, so I'll simply come out from VI editor. Now once this file is there, you need to make sure you change the permission and you assign execute permission to this. So I'll change the permission. I have assigned universal execution permission to this one. Now we need to edit one of the files which APC UPSD will call whenever there is an event, and the file is in the same directory, etc apc upsd, and the file name is apc ups apc control. Yeah, so this is the file. Now there is lots of stuff in this file, but if you move down from this assignment portion, you see section where they ask you to add Perl or C program if you want to call any additional script. So I'll go to the end of this comment block, and this is where I'll create some space, and I'll add one line which is Python. So I am going to execute a Python script, so that's for Python on the directory where the file is located, so etc apc upsd. Yeah, so it is correct. So after this mqtt events publisher.py. So this is the file name. It is under etc apc upsd directory. File name is mqtt events underscore publisher.py. Now this file is expecting some kind of input, right? So there is a command line option which I have defined in the Python script. So for that there is a variable. So the first command line argument which is passed or which will be passed to this APC control file, we are using that argument and passing that into our Python script, right? So we are done here. I'll simply save and quit. Yeah, so we are done with this configuration. Now every time whenever there is an event, APC UPSD service will invoke APC control file, and in that file we have added our script, and we are using one of the parameter which APC service is passing to APC control file. And this is how we will take all the events from APC UPSD service and passing them to our MQTT broker. So now our Raspberry Pi is configured with APC UPSD and the Python script which will forward all the power events to MQTT broker. So it's time to test it quickly. So here I'm using an application which is MQTT Lens. This is actually Google Chrome application. So if you go to Google and type MQTT Lens, you will be able to find the link, and then you can install it onto your machine. It is very easy to use, so you need to create a connection. So I'll go ahead and do that for you here. So connection name, you can do anything. So the default one, it is showing as Eclipse MQTT, so I'll use the same one because we are using Eclipse MQTT broker. Now the broker IP or DNS name, again we are using ioteclipse.org, so we'll use the same thing, iot.eclipse.org. The default port is 1883, so need not to change that. Generate ID, let's generate a new ID. Clean session, automatic connection, fine. Keep alive 120, fine. We are not using the username and password, anyways this is just a demo. So I'll remove the username and password thing. I'll click on create connection. So this will create a connection with the broker. So as you can see, the status is connected now. So MQTT Lens is connected to Eclipse MQTT broker. Now you see there are two options here. One is Eclipse, subscribe, and other one is publish. So whatever topic you want to subscribe to, you need to type that topic here and click on the subscribe button. If you want to publish something on some topic, simply type that topic here, type your message here, and you can click on publish. So that message will get published on that topic. So the file that we are using, we used a topic which is test topic. Now you need to make sure you put your topic here. So I'm putting the one which I have on the Python script, APC UPS events. So this is the topic which I'm using in the file. So I'll click on subscribe. So it is subscribed to this topic. Now whenever there is an event, you will see the event message coming to this topic here. Now if you don't want to use MQTT Lens, I have uploaded another Python script on Git, and you can download that Python script and execute that onto your local machine. Make sure you change the broker IP or DNS name if you are using something else, and make sure you put your own topic. So I'll execute that Python script also, so that we can see the messages are coming on both the clients. So it's a Python script and subscriber.py. So I'll start this. So now it is listening to the same topic. I have already configured that inside this script. So now this is my Raspberry Pi console. This is my local machine console here, and here I have MQTT Lens. So I'll go back to Raspberry console. So I'm here on Raspberry terminal window. I'm logged in with the SSH. So what I'll do now, I'll turn off the power for my UPS, and you will be able to see some broadcast message from the UPS on the Raspberry Pi, because this is the direct host which is directly connected to the UPS using the serial cable. So I've just powered off the UPS. Now you see the broadcast message, and it says power failure on UPS, and APC underscore UPS is the same name which we configured in apcupsd.conf file. Now if you see here on MQTT Lens, there are two messages which is like power out, and the second message is on battery. Now if I go to the Python script which I have written, you see both the messages are here also, right? So power out and on battery. Now I'll go back to Raspberry Pi and I'll switch on the power to my UPS. Now you will see another broadcast. So power has returned on UPS. So this is what you see on the local host. Now if you go to Lens, you see mains back, off battery. Now same thing I should have on my local Python script also. Yeah, you see there are two new messages, mains back, off battery. Now using this, you can transfer all the information related to UPS onto MQTT, and then you can write other client applications, or you can write other scripts which can perform some other operations. Whenever there is power out, you can turn off some devices gracefully, even if they are on some unmanaged UPSs which cannot turn it off, and things like those. So there are multiple use cases which are possible with this kind of thing, and because you are using cloud-based MQTT Broker, it doesn't matter where you are. So if you install a MQTT client on your mobile, you will see all these messages on your mobile phone directly. So yeah, this is it. One more use case, probably before I close it, I'll explain you. So if you remember the service APC UPSD status, right? So if you see this, there are some very good things in this output, right? So you see the host name of the Raspberry Pi, right? You see the start time, you see the UPS name, right? The exact model which I'm using, whether it is online, offline, what is the input voltage to this, right? The load capacity, you see 0% because I have just a Raspberry Pi connected with this at this point of time. So you see almost zero. Now battery charge, 97% battery is full. Time left is 109 minutes. Um, so you see all those things are there, right? So you, if you want, you can write another script which can run this command and then parse out this information and send all of this in MQTT. Or you create a web page with very nice graphs where you can show the battery level and things like those. So it's up to you um, um, what all you want to do with this kind of a model. So that's it for today. Thanks for watching. Have a good one. Bye bye.